Moving on to this Paris Agreement and its implementation, the chapter is more on the aspects of what failed with Kyoto Protocol and in general the international negotiations, and what made Paris Agreement possible and what challenges it actually faces in its implementation. So there are some interesting tidbits to go through here, even though it's not clear that the methodology can be used to make the agreement more successful, except to learn a few tricks on how to reduce defection, how to incentivize action based on co-benefits, and why the approach under Paris Agreement may be better than the Kyoto Protocol, and why it may have a better chance of success, and so on. Looking at a brief history of these negotiations, mostly focused here on US. So the IPCC panel was born in 1988. There's a history of other international activities like the Stockholm, Brundtland, etc., which were not as specific, but they did have the general ideas of sustainability, climate change, global warming, and so on. UNFCCC was formed in 1992, and the whole process took basically, I think, about 2 years, which is considered relatively fast, but as we will see, apparently it was fast because it didn't really mandate anything. It provided a framework convention for climate change, but beyond that, all the challenges came to the fore when Kyoto Protocol was being negotiated as the world's first greenhouse emissions reduction treaty. Okay, so here global average temperatures should not exceed 2 degrees above pre-industrial level was coded into the EU Environmental Council conclusions, which the 2 degrees centigrade target, as we said before, is not completely geophysical or based on climate science as such. It was raised by Bill Nordhaus in the 1970s as some kind of a threshold. He's an economist, so you have to remember that. And then the Stern report and EU took it up. IPCC has taken it up, and in fact has even looked at how much better things will be if we went to 1.5 instead of 2, or how much worse things will get if we cross to 1.5 into 2. Okay, the Copenhagen Accord, we'll talk a little bit more about, is considered a spectacular failure to accomplish the goals. But here, strengthening the long-term goal of 2 degrees C on the basis of best available scientific knowledge, including in relation to a global average temperature rise of 1.5 degrees centigrade. So there was the idea of looking at 1.5 versus 2, and we will see that the emissions have continued to increase despite this long history of almost 2.5 decades of climate negotiations. Okay, so 2009 Copenhagen is generally considered a failure, which actually acted as a wake-up call. So the Cancun Agreement in 2010 was the first review period of the long-term global goal. Paris Agreement 2015. So Cancun Agreement went on here into the Paris Agreement of 2015. IPCC invited to prepare a special report on 1.5, and pretty detailed reports were put out. Land use change turned out to be a kind of a key concern, as not being considered in its full scope as to its ability to mitigate and reduce greenhouse gas, mitigate climate change, reduce emissions, sequester carbon, etc. So, Paris Agreement holding the increase in the global average temperature to well below 2 degrees centigrade above the pre-industrial levels, and pursuing efforts to limit temperature increase to 1.5 degrees above pre-industrial levels. If we continue on the emission trajectories we're on right now, then it's only a question of how soon we will hit 1.5. Okay, so by all measures, we are not on track to remain below 1.5, but these kind of targets have lots of other issues. When you say exceed 1.5, is it just a blip? You go back, you go up and come back, or you have to stay in 1.5 for a decade, 2 decades? How long? So these are kind of issues that are social science, economic issues that cannot be just ignored. So these targets have to be taken in that context, that they are not as well defined. Plus, the targets are meant to be met with a certain probability, because everything you do in terms of choices on technology, policy, global governance, renewables, etc., will move you towards 1.5. So what probability do you have of avoiding it? 66% is kind of considered very good. If you can hit 1.5 degrees with a 66% probability with all the choices, some of which we will look at, then it's a good target, right? So the scoping meeting of the SR 1.5 happened in 2016, preparation and the review stages of SR 1.5, and 2018 approval session for SR 1.5. I think all the reports came out in 2019, if I'm not mistaken. So this is the same timeline with many more details. Obviously, I won't go through all of them. The Conference of the Parties 1 started in 1995 under the UNFCCC, the United Nations Framework Convention on Climate Change. There is a US history involved in there with Clinton, Bush, Obama, and so on. But US opted out of Paris Agreement in 2017 after Trump took over, and again there was an official vote to get out of it, I think as a referendum, if I'm not mistaken. But the point is that there is no solid leadership on global action. Lots of negotiations, and the Paris Agreement is definitely a good start in terms of the bottom-up approach, more democratic approach, which allows countries to experiment consistent with their own goals, learn their lessons, and maybe bring the lessons to the table so other countries can use them as well. Okay, as opposed to Kyoto Protocol, which was top-down and basically was a failure at this point. Okay, here is data from NOAA showing that CO2 has continued to increase. This is into 2019, I think, maybe, or 2018. Methane, which has a slightly different behavior, not completely understood, but it flattened out a little bit and has been increasing again. Nitrous oxide, note the units, these are in parts per million by volume, whereas methane and nitrous oxide are in parts per billion, whereas CFCs and HFCs are in parts per trillion. So as you remember, the concentration matters, the residence time matters. For example, CO2 can stick around for hundreds or even 1,000 years or longer. Methane is about 12 years. Nitrous oxide, I think, is a couple of centuries. HFCs and CFCs, it depends on the use, and the dominant one is probably something like 25 years. But their global warming potential also matters. So for the same amount of increase over a period of time, how much global warming will they cause with respect to, let's say, CO2, which is considered 1. So methane is about 25, nitrous oxide is around 200, I think. You can check. CFCs and HFCs are anywhere from tens to hundreds of times of CO2. Okay, so that's kind of a start of the discussion on Paris Agreement, and we'll see a little bit more details about why Paris Agreement was successfully negotiated and why it may have a good chance of success compared to uh, Kyoto Protocol, but the challenges that Paris Agreement faces also have to be looked at.